Section 9.2 is about the graphs of quadratic functions. We've been solving these for a while now and working with them for a bit, so let's practice how to graph them. So a function f is a quadratic function if f of x is ax squared plus bx plus c, where a, b, c are real numbers and a doesn't equal 0. Because if a equals 0, we'd have a linear equation. So the graph of any quadratic function is a parabola with a vertical axis of symmetry. So this example right here is y equals x squared. It's the squaring function. It's the simplest quadratic we could have. It does have a vertical axis of symmetry at x equals 0. So, like I said, this is the squaring function, y equals x squared. Its domain, some facts about it, goes from negative infinity to positive infinity. That's the domain of all quadratic functions. What changes is the range. So for this squaring function, its range is 0 to infinity with 0 included. Its vertex is where it changes from looking like it's decreasing to increasing, right? To negative slope to positive slope. This is going to be its vertex. Its axis of symmetry goes through the vertex, and it's continuous over its entire domain. Now, what does that mean? Well, continuous over its entire domain means I could draw it without having to pick up my pencil. And that's the definition you should use in this course. So as you can see, 0, 0 is a point, like 0 squared is 0. Negative 1 squared is 1. Negative 2 squared is 4. 1 squared is 1. 2 squared is 4. So it does have that axis of symmetry. If I was to fold it in half, our graph would lay over itself. So if I have the graph of f of x equals x squared plus some constant, it's going to have the same shape as our squaring function, but it's shifted k units along the y-axis vertically. And its new vertex would be 0, because x is still 0, because we're shifting it vertically, k. And it has the same axis of symmetry. Now, if k was positive, it's shifted up. But if we had k was negative, like f of x minus equals x squared minus, in this case we say c. See, it's shifted down, but it's going to have the same shape. So if I have f of x equals x squared plus 3, what I'm going to do real quick first is graph our standard quadratic function, our squaring function. This is a tiny little graph. Okay, so this is y equals x squared. And my new function, f of x equals x plus 3, it's the same function except what happened? Well, it's going to be shifted up 3. Let me show you. So if I have negative 2 squared plus 3, that gives me 7. Negative 1 squared is 1 plus 3 is 4. 0 squared is 0 plus 3 is 3. 1 squared is 1 plus 3 is 4, right? So this graph has been shifted up 3. So this would be our new graph in orange, right? It has the same domain. It has the same axis of symmetry, but my range has changed, the possible y values. Now my range goes from 3 to infinity. This graph was shifted up 3. We added 3 to our y values. What if I have x squared minus 5? How is this graph going to be shifted? So let's go ahead and graph our basic squaring function. And you don't have to do this every time. This is just for us to kind of visualize the shift. So I'm saying what we're doing now is we're shifting this graph down 5. So I'm going to take every point, if I wanted to graph it this way, and shift it down 5. So my vertex moves down 5. All my points move down 5. So what are my new points when x is negative 2, negative 1, 0, 1, and 2? And then we'll verify them with the equation. We're going to state the range. The range is more important than the domain. The range is what changes. So here's my new parabola, shifted down 5. So when x is negative 2, I said here, okay, it's negative 1. Let's check that. Negative 2 squared is a positive 4, minus 5 is negative 1. Okay, that worked. What about negative 1? Well, negative 1 squared is negative 1, is a positive 1, minus 5 is a negative 1. And we know we've got, negative 4. It's positive 1 minus 4 is 4. I had a moment. And we know 0 squared minus 5 is negative 5. So we can either graph them by graphing our squaring function and moving them down, or by plugging in some points. It's up to you. So my domain is negative infinity to positive infinity. My axis of symmetry is the same. What's changed in this case is the range, which now goes from negative 5 to positive infinity.